All right, folks, welcome back. We're going to take a look at section 5.2 today, which is on angled bisectors and perpendicular lines. So some more stuff that we can do to deal with angles and triangles. We're going to start with looking at the term bisect. Bi means two, and sect means cut. So bisect means to cut in two, and bisecting a straight line is to cut something into two equal parts. Now, one way of remembering what sect means, if you are Harry Potter fans, and you remember in the Half-Blood Prince, the spell sectum sempra, which sliced into the opponents, sectum, that means to cut, right? Sect, bisect. Anyway, just a little bit of Harry Potter trivia for your entry into this. And I've totally skipped over the first page. So I'm going to go back just for a moment. This is the review from yesterday's class. So take a look at this. Pause the video. See if you can solve these questions. I'm going to start working through them. The complement of an angle is 37 degrees. What is the size of the angle? Complement. We know complement and supplement, right? Complementary angles and supplementary angles. One of those adds up to 90 degrees, and the other one adds up to 180 degrees. Which is which? Which is which? Supplementary starts with an S, and so does straight line. Straight lines are 180 degrees, so supplementary adds up to 180. Complementary must be 90 degrees, right? This is what you might think if you, like your mental process as you're trying to do this, and remember how to do these questions. That's my mental process. I'm just voicing it aloud. Okay, so the complement of an angle is 37 degrees. 90 degrees minus 37 degrees equals 53 degrees. So the size of the angle, if its complement is 37 degrees, that means the original angle is 53 degrees. The supplement of an angle is 146 degrees. What is the size of the original angle? So the angle that is not the supplement, or what's the supplement of this angle? Because they're reversible. So the supplements, we use straight lines, which are 180 degrees. 180 minus 146 is going to be 34 degrees. And finally, we have a true bearing question that we learned last time. And whenever you're doing a true bearing question, it really, really helps to draw it out. We've got a boat traveling 48 degrees south of straight east. So we draw our compass. This is north, south, east, and west, or never eat shredded wheat. Okay, 48 degrees south of straight east. Straight east is this way, and we're 48 degrees south of that. All right, 48 degrees coming down this way. So how do we do true bearing again? We start at north, and we go clockwise until we get to our angle. So if this angle is 48 degrees south of east, that's not a very well drawn 48 degrees. Remember, 45 is right on the halfway between east and south. But here, this is going to be 90 degrees. This is going to be 48 degrees. So true bearing equals 90 plus another 48, or it's going to be 138 degrees. True bearing. Okay. All right, that's it. As a review from yesterday, hopefully you were able to get those questions. Let's move on now to sectum sempra. Sorry, no, bisectors and perpendicular lines. I will not be teaching you the spell to name each other today. Okay, so a bisector, to bisect something is to cut something into two equal parts. An angle bisector is a line, or what we call them in angles is a ray, that separates an angle into two halves of equal measure. So if a ray will bisect the angle if the two halves have equal measure. So if this is our original angle, we want to add a bisector. That's going to be another line that cuts this exactly in two. That's not exactly in two, is it? There must be a better way to do this. Notice there's a compass over here. So maybe I should delete this part and do this a little bit better. Okay, let's bring this compass over. First part of this is going to be to figure out exactly what this angle is. And we're going to mathematically cut it in two. Oh, this is not easy to see. It's probably even worse for you guys. Right now, I'm looking at my compass. In order to use a compass, can I zoom in on this? I don't think I can easily. In order to use a compass like this, let's see, bigger. There we go. So we're going to start by putting the, as you can see in the compass, we've got this little square in the bottom. We've got a line at the halfway point. We're going to line up this bottom line along with one of the lines in our angle that we're trying to measure. And we're going to put this square part right in the corner where the two rays meet. We're going to try to be as precise as possible. Get that right there. Make sure the line's lined up. Then we're going to read where the next line goes to. In this case, it's pointing at the 80 or the 100. So there's two numbers here on this particular compass, 80 degrees and 100 degrees. How do we know which one we want to use? Well, the question is, how big is our angle? You have a reference that you should be able to identify all the time, which is a 90-degree angle. Is this angle here smaller or larger than 90 degrees? Well, as you can see, 90 degrees and 90 degrees are both right here. This is a little bit smaller, so we're going to read 80 degrees. If our original angle is 80 degrees, then we're going to cut that in half, which is going to be, whoop, I can do this, 40 degrees. Right? Our angle bisector will go at 40 degrees. So that ending is going to go here, and oh, I buried it now. This is actually closer to there. How's that? That's terrible. Yeah, I better bring it back down again. So we're going to make sure when we use our compass that we put it exactly at 40 degrees. One of the better ways to do this, rather than just trying to eyeball it, is you take this 40 degrees, and obviously I can't put a point here, right? My compass is in the way. Where am I going to have to put my point? I'm going to have to put my point out here. So now I've got a point out here. I'm going to take my ruler, or the bottom of my compass, and then I'm going to take this line, and I'm going to connect it through that point. How do I do this? It's going to let me. Trying to lock down. Anyway, yeah, so you'd want to connect draw your line straight through that point that you determined by drawing outside the compass. That's going to be the best way of drawing it. Similarly, if you have to measure something and you can't see exactly where it lines up, feel free to take your ruler and extend that line so that you can see where on these lines, like the exact place that it moves to. Maybe able to show you that with the next one. Okay, so bisect angle ABC using a straight edge and a compass. I'm going to bring my compass again, and need a bigger compass than that. So once again, to measure this angle, we're going to take this point, put it where the point of our triangle is, right? This square at the bottom, line up at this bottom line. And then you're going to take a look here. Okay, so we have a line. I can't see right to the edge. What I'm going to do is actually going to extend this line. Can I do that easily with this? Maybe not. Okay. Instead of extending the line, I'm going to shrink my compass. Seems like cheating. But you would extend this line and then see which line it goes through. I'm going to shrink my compass so that I can see which line it goes through more easily. As you can see now, I've got it right on one of the lines. It's between 140 and 150, or between 30 and 40. Again, what do I read? Is it 143 or is it 37? Well, this is Acute angle, it's so cute, it's so little, right? That's an acute angle. So it has to be less than 90, so I'm going to read between 30 and 40. And there's no exact markings between 30 and 40, but the angle degrees are the same. They're still 10 apart. So I can take a look at this one. Notice that it's 3 away from 140. So it should also be 3 away from 40. Is it going to be 43? No, because it's between 30 and 40. So that's going to be 37 degrees to start with. Now, how do we bisect it? How do we bisect an angle? We take this, we're going to divide it by 2. You get 18.5 degrees. That's going to be half of our angle. So then we're going to take our 18.5, which is going to go between 10 and 20, and 1.5 degrees away from 20. We're going to draw it on the outside here. So that's 1.5 degrees. And now we're going to take a straight edge and we're going to draw a line from here through that angle with you. You guys will have a ruler to do that with and draw out your 18.5 degrees. That's how you draw a bisector using a straight edge and a compass. Next topic today is perpendicular lines. These are lines that form a 90-degree angle, what we also call a right angle. So these two lines are perpendicular. Or we can also think of this as a straight angle, and that's a bisecting the straight angle. It's cutting that straight angle in half, right? Because this straight angle is 180 degrees. If you cut that angle in half, you get 90 degrees and 90 degrees. What about if we cut it in half again? If we were to cut this in half again, what do we get? We get 45 degrees and 45 degrees. Again, that 45-degree angle is the halfway angle in our right angle. And then those 45s are complementary, right? 45 plus 45 is 90. Our 90-degree angle here and our 90-degree angle here, those are supplementary. All right, so how do we know when two lines are perpendicular? What does perpendicular mean? It means they meet at a right angle. So how do we know that that's true? We use a compass. Sometimes they're going to be right there, sometimes they're not. So we take our compass, we put it in put this middle bit where our angle starts, and then we measure. Look, that's 90 degrees. This one here, no, that's 100 degrees, right? It's at the 80 and the 100, but it's larger. I guess it depends on whether you're reading this 80 or this 100. It's larger. How about these ones? Are these perpendicular? No, they're not at the 90-degree mark. What about these ones? Are these ones? Oh, this line isn't straight. I'm going to have to adjust my compass slightly. Make it easier to see. Put that right in the middle. Oh, it is right on the 90. So L5 and L4 are perpendicular. Sometimes we'll use this notation. Okay, we draw a pair of perpendicular lines, like this upside down T shows the two lines are perpendicular. L1 and L3. L1 is perpendicular to L3. Are there any other perpendicular lines in here? I don't believe so, because these aren't pairs. This can't be perpendicular. This one's at too much of an angle. Neither one of those looks like a perpendicular. I measured that. It's not. So yeah, that'll be our two perpendicular lines. Here, here, and here, and here. Finally, we get into the fun stuff with triangles. I love this stuff. We got a carpenter inlaying different types of wood on a tabletop. what must be the size of angles A, B, C, and D? This is where our complementary, supplementary angle stuff comes in, finding out extra stuff. So there's some stuff. Remember that the angle measures in a triangle all add up to 180 degrees. The angle measures of a straight line all add up to 180 degrees. The angle measures of any right angles add up to 90. So we got to solve for A, B, and D, oh, and C and D as well. How do we do that? What do we have that we can solve for right away? Well, let's start with the very beginning, the first letter, A. If we look at this angle from here to here, we've got a straight angle. We've got a straight line, which means that all of these angles that make up this straight angle have to add to 180. So A equals 180 minus 60 minus 75. So that's 135. This is going to be 45 degrees. A has to be 45 degrees, so that 60 plus 45 plus 75 equals 180. Cool, so we got A. We can do the same thing for B, right? 180 minus B equals 180 minus 75 minus 55. 75 and 55, that's 130. 180 minus 130 is 50 degrees. So B is 50 degrees. Cool, that was fun. Now, oh, C. Oh yeah, I've got enough information to calculate C. I've got a 50-degree angle here, 75-degree angle here, and an unknown angle here. But they are all part of the same triangle. So that means that C and 50 and 75 all add up to 180 degrees because every triangle is 180 degrees. So C equals 180 minus 50 minus 75. It's 125. So it's going to be 55 degrees. And finally, we have D. Ooh, I don't have enough information down here. However, 75, 75, and D, this is another triangle, right? So the same is true. All the angles in a triangle add up to 180. So D equals 180 minus 75. 75. So D is going to be equal to 30 degrees. And so we've gone through, we've taken one clue at a time, solved for all of these missing angles. Using these properties we now know that are supplementary angles, we've got 3 angles that are supplementary in this case, so all 3 add to 180. And also by using our total angles within a triangle, adding up to 180. I could have also calculated this first from this triangle, because this is 55 and that's 90. So I could calculate the complement to C and then figure out C, but I had the information here, so I didn't need to. All right, hopefully you understood most of that. Section 5.2 beckons in your workbook. Give it a good read through, and when you're done that, do the first quiz, please, for Chapter 5, which is on sections 5.1 and 5.2. If you want to, I do have a quick review of some of this stuff at the beginning of the next lesson. You could test yourself on that before going into the assignment. Up to you. Anyway, I'll see you at 5.3.